Okay, I want to take a half a second here and talk about how plant physiology works. Okay, and it's the same in a plant, it's the same in the animal, it's the same in a human. All right? We have 9 elements that are basically the building blocks for plant structure. Okay, we have roughly 50, 60, 70 trace elements that actually are what they call activators. Okay, this would be this in essence is a fuel. Okay, now there's another little cool thing in nature called an enzyme. Okay, does anybody tell me what enzymes do?
Yeah, break down.
Ah, they do. They do. Can they also put things together?
Yeah, they put them together.
Okay, that's $200 answer right there. Okay, so they're going to break down.
You should say where enzymes come from. We talked up till now, but
Okay, sources of enzymes. Okay, plants, animals, humans, microbes all come with enzyme packages. Okay, we're not short enzymes. Okay, God did not miss that part of the programming. Every organism has its own specific enzyme package. Okay, whether they work or not depends on activators. Okay, so for example, let's just say that I've got a soil, I want to fix nitrogen. Okay, I want to get some of that free N2 gas out of the air, and I've got rhizobium or azotobacter. Okay, for a $300 question, which trace element activates the enzymes that produce nitrogen? Ed, you cannot answer this. Has a molecular weight of 99. Any of you ever heard of molybdenum? Your nitrogen-fixing bacteria can't operate their enzymes to take nitrogen N2 gas out of the air and put it into a different form. The enzyme that runs that requires molybdenum as its activator. So, B2, B6, B12. You have to have cobalt to develop any of your B vitamin groups. Can't get it without cobalt. How many of you guys have enough cobalt in your soil? Please don't raise your hand, because you don't. Most of you guys have 1/100th of the minimum. Okay? So, and that's the minimum of the low end of minimum. Okay? You're 1/200th of the upper end of the minimum. Okay? It's not there anymore. Every time we've grown plants, we've taken out molybdenum and cobalt and strontium and gallium and vanadium and titanium and chromium, and we've taken out zinc, copper, manganese. All of these wonderful minerals, we take them out and we put them in our birds, we put them in our milk, we put them in our wheat, we put them in our hogs, and they went down the road. And we put back NPK. Now, what's happening is we are short trace minerals to activate enzymatic systems. Zinc runs almost 400 different enzymes. Potassium. Now it's one of these dual guys. It's a major part of the structure, but it also runs almost 400 enzymes. Manganese runs enzymes. Copper runs tons of enzymes. Okay? All these minerals are taking and they're activating these enzymes, so the enzymes can take raw product, your N, P, and K, calcium, sulfur, magnesium, and make roots, stems, grain, bones, teeth, beaks, eggs, steaks, potatoes. This is, everything gets put together by an enzyme. Now the cool thing is enzymes run 100% of every living function in every living organism. You and I cannot process a thought, move a muscle. We'll never blink an eye without an enzyme running it. And there are no exceptions. Anything above a rock. It's all enzymatically operated. Now, we produce our enzymes. Microbes produce lots of enzymes. So, do you want to buy enzymes? Or do you want to buy the manufacturing plant of enzymes? Because when you buy enzymes, you're going to buy a specific amount for a specific time. When you buy the microbe and you put that guy in your soil, if you don't kill him, he can be there, or his offspring can be there perpetually, producing all kinds of enzymes, all kinds of compounds, all kinds of nutrition. Now, we'd have agriculture down to a T if we could get minerals to multiply like microbes. Because we'd only have to buy a pound of nitrogen and put it out there and let it multiply billions of times over. We'd have all the nitrogen we need. Or phosphate. Buy a couple pounds and just kind of put it out around the farm and let it reproduce. Right, Abe? Solve all of our problems. When you deal with biology, you have the potential of reproduction. And that's the critical part. These microbes produce the enzymes that restructure things. We produce enzymes that we restructure things. Okay? This is how nature puts things together. And if we don't have trace minerals or enzyme activators running these enzymes, we don't get compounds put together. Okay? So, we're going to talk about plant primary metabolites, plant secondary metabolites. This is what's driving this whole system. You can't get your N, P, and K changed from unusable forms of fertilizer into usable plant forms without microbes having trace minerals to utilize your NPK stuff. So your NPK efficiency depends on my trace minerals being there to activate my biology. Who's got the enzymes to do this? Mycorrhizal fungi, what does it produce? Leonard, any guesses? I haven't taught you this.
Feeds biology, don't it?
Mycorrhizal fungi are microscopic mycelia that attach to the root. Okay, like rhizobium. Okay, they attach in your root and they form nodules, right? Got it. Okay, rhizobium do this, or mycorrhizal fungi do the same thing. They go in, they attach into the root, they feed off the plant sugars, and they grow and they go out in the soil like cobwebs. Mycorrhizal fungi can gather up to 95% of your plant's phosphate requirements. That's pretty cool. I can harvest unusable, unsoluble phosphate from my soil with another microorganism. Pseudomonas does this. Bacillus will do this. Okay? If they're there, and if they have the trace minerals to help them do this. And I promise you, the ability of a mycorrhizal to mine and extract phosphate is about 1,000 times better than your plant's ability to extract phosphate. So you know what the plant says? I'm no dummy. It's way easier for me to get sunlight, make a few sugars, feed the mycorrhizal, and let him go do the heavy lifting on my phosphate and my trace minerals. Let him go mine that soil, because he'll do it easier than me, and I'm up here, I got sunlight anyway. I might as well share a little bit of the energy with him. And so nature knows how to use each other. And so the plant, when we go back and we look at our plant needs for phosphate, the plant knows exactly when it needs phosphate or potassium or nitrogen. And what it will do is it will change its exudates, it will recombine its sugars to feed the microbes to say, go get nitrogen, go get phosphate, go get calcium and potassium. And so what we don't realize is these plants and these microbes are having this dialogue every day. Hey, guess what? I'll feed you if you feed me. And so I need to get these guys going today. I need to get these guys going. And so I'll just change my exudates. I'll just restructure my food source for these guys. These guys like steak. These guys like hot dogs. These guys like chicken. Okay, I got to feed them for them to go do their work. It's all in constant communication. And so this whole process of taking an enzyme and activating it requires minerals.
Does a certain soil temperature shut these guys down like in the winter? They go on break or what?
Yeah, they head south. They'll go all the way to Mexico. Okay? The cool thing is microbes will hibernate. Okay? And they do. When soil temperatures go down, they go down. So this is why we use a starter fertilizer in the spring. When soil temperatures are cold, it affects the soil chemistry. So when you have cold soils, you're not going to pick up calcium, you're not going to pick up phosphate. So oftentimes, we'll put down 3 or 4 gallons of liquid phosphate as a soluble immediate source of those minerals, because the soil, because of its temperature, hasn't released the electromagnetic bonding, and the microbes are saying, it's too cold to come out and play, and I ain't coming out. So we put in a soluble source to get the plants up and going, and then once the soil warms up, then the natural systems kick in place. So it's just back to how do we manage that environment at the time.
And water. Water's a big deal too on microbes, make them go.
Well, yeah, that's another factor. When the temperatures get down really cold, okay, you have different zones for beneficial microbes, okay? So, what happens if I take a seed and I plant it in 45-degree soil? What's going to happen to my seed?
It's not going to sprout.
It doesn't want to work, okay? But what does work in that 45-degree soil? Or that 40-degree soil?
The bad guys.
The bad guys. These guys are going, wahoo! Guess what? They just put some seed out there and we're going to tear it apart. And they're going to have days or weeks of having their way on this seed, because these cool temperatures are their environment. Now, when we get up into the 50s, 52, 55, 60, okay, the pathogens, it's moving against their environment. Now the good guys are coming in and the soil minerals are starting to release and kick in. Okay? So if we're just aware of what goes on in the soil with our mineral release and our biology groups, then this is why we don't plant seed in cold soils. Those pathogens will tear it apart because it won't germinate, it can't pick up the minerals, it can't grow, it can't get energy, and it can't defend itself. And it is like the only white guy in the Bronx with a lot of money at night. You aren't going to have very good chances. Okay? So, the plants, the very first thing that they build, plant carbohydrates, proteins are next, fats and oils are next. Okay? So carbohydrates are nothing more than carbon, hydrogen, oxygen. Okay?
On this cooler seeding, cold seeding, like early seeding, You got seed treats that takes care of that, right?
You put on a poison to stop the bad guys from coming in and making merry with your seed, right? That's a way of doing it, okay? And we have soil pathogens out there. So chemically is one way of dealing with them, okay? Biologically is another way of dealing with them, okay? So, again, all systems are driven by enzymes. Enzymes run every living function in every living organism, and then the activators are your trace minerals and your vitamins. So when your mom told you to take vitamins when you were a little kid, she was a lot smarter than you thought. Vitamins activate enzymes just like trace minerals do. If they're missing, the functions remain dormant. It's just like fuel in a tractor. No fuel, no worky. Simple as that. Okay? Enzymes are supported by biological microorganisms. Enzymes are destroyed by pathogenic organisms and environmental toxins. We can denature enzymes very quickly. Okay? We have things that put things together, construct, and decompose. We talked about this. Vast majority of all of your enzymes are proteins, so we've got to have nitrogen to do this. Okay? Enzymes increase the reaction rates by thousands or millions of times. Cofactors. Okay, my inorganic metal ion cofactors are my trace elements. My organic cofactors are my fat and water soluble vitamins. Okay? We can take the enzyme and we can look at the function of what it's doing inside the plant. And so we have a few examples here. Nitrate reductase converts nitrogen from NO3 to NH2 or NO2. Right here, nitrogenase is the enzyme that takes atmospheric nitrogen and it fixes it for legumes. Okay? These are the enzymes. So we can go up and down the scale. This one right here, superoxide dismutase, that's what keeps us alive. That's what keeps plants detoxed. That's what keeps your animals detoxed. Okay? Amazing, amazing. Okay? All of these enzymes doing all of these functions. I just wanted to show you this so you didn't think I was making it up. These are your vitamins. B1, B2. These are the cofactors. These are the enzymes, and this is what they're doing. Okay? I have 50 pages of this stuff. I'm not guessing. Okay? You can go through and research all this stuff, and if you have time, you can find out all this really cool stuff, what all these vitamins are doing, how everything works inside these systems, and it's all connected. Okay? Niacin, folic acid, biotin, CoQ10, vitamin C,